So in continuation, again, this is transformation by using trigonometric function, using our first formula or type 1 transformation. With type 1 transformation, this is now integral of sine or trigonometric function sine raised to nu cosine raised to mu du, where both n or m are all positive odd integers. So meaning, ang consider lang natin dito using the solution for type 1 formula and the transformation of trigonometric function are positive exponents or positive odd exponents. Applicable type of identities in this particular formula is sine squared theta is equal to 1 minus cosine squared theta all over cosine squared theta, or cosine squared theta equal to 1 minus cosine squared theta. Now, what if, as our first example, you're now asked to evaluate the indefinite integral, number 1, the indefinite integral of sine cube x dx. Pinaka-basic na yan. Pinaka-basic problem. So, remember, positive odd integers. In this given problem, meron tayong positive, and it is also it is a positive integer, and it is also a positive odd integers. So meaning we can apply this particular formula for this problem. First up is for us to play with this integrand first. Given that it is sine cube x, for us to apply these identities, kailangan natin yung sine squared. With that, we know that we can also express this one as sine squared x times sine x, right? Knowing that that is already sine squared x, we can also express that as 1 minus, this is 1 plus. This one is supposed to be 1 plus minus sine squared theta. And sine squared theta is also equal now to 1 minus cosine squared x times sine x dx. Simplify further, distribute lang natin yung ating sine x doon sa ating term. That is now sine x minus cosine squared x times sine x dx. Distribute our antiderivative. Gives us sine x dx minus cosine squared x of sine x dx. Similarity of terms. Integral of sine x is basically negative cosine x. Cosine squared x and sine x. Our u here is simply equal to cosine x, a term or trigonometric function term that has greater exponent than the other. So, mas malaking exponent ni cosine kaysa kay sine. So, we'll consider using cosine. So, cosine, differential of cosine is negative sine x. So, we'll need to introduce a correcting factor, negative 1 over sine x du. Para makancel yan and yan. Then will give us a final answer, or the integral form of cosine squared x plus cosine squared x sine x is positive cosine cube, apply power rule, over 3 plus c, which is now our final answer for this problem. Number 2. What if you're now asked to evaluate the indefinite integral of cosine raised to the 5th power 2x times cosine raised to the 4th power times to the 5th power times sine raised to the 4th power 2x dx. This is our second example. Remember our first transformation formula, type 1. An exponent or trigonometric functions or terms that should has an exponent or have an exponent of positive odd integers. Meron tayong odd integer, meron tayong even integer. Even positive integer and positive odd integer. So ano yung pwede nating i-transform dyan? Starting tayo with cosine 5. We can also express cosine raised to the 5th power as cosine squared 2x raised to 2 times cosine 2x times sine 2x raised to the 4th power dx, such that we know from identities that cosine squared x is simply equal to 1 minus sine squared theta or sine squared x. Similar with this one, that is 1 minus sine squared 2x squared cosine 2x times sine raised to the 4th 2x dx. We cannot eventually apply or furtherly solve this part of the problem as it is. So basically, expand lang natin yung ating term within the parentheses. So that is 1 minus 2 sine squared 2x raised to 2 plus sine raised to the fourth power 2x times cosine 2x sine raised to the fourth power 2x dx. We could then distribute the term outside the parenthesis. So it is now cosine 2x of sine 4 2x minus 2 sine squared times sine raised to the fourth is basically sine raised to the 6 2x of cosine 2x plus sine raised to the fourth times sine raised to the fourth is simply sine raised to the 8th power 2x times cosine 2x, then your dx. Simplify further, distribute our antiderivative or integral sign with each of those terms. That is cosine 2x, sine raised to the fourth 2x dx minus 2 sine raised to the 6 2x cosine 2x dx plus sine raised to the 8th power 2x cosine 2x dx. Notice the similarity of each terms. If we differentiated 2x, we cannot basically integrate both of these terms, cosine 2x and sine 2x. Meron pa siyang exponent and we cannot perform double integration or perform two rules of integration or two integral formulas in one integrand. Hindi po pwedeng sabay-sabay. So, isa-isahin natin. Consider natin that one of these terms or this trigonometric function cosine and sine has the larger exponent than the other. So, most of them, sine 2x yung mayroong mas mataas na exponent. So, consider natin si sine 2x as our main function. Differential of sine 2x, that is 2 cosine 2x. So, notice meron na tayong cosine 2x sa bawat term. But wala si constant 2. So, basically, mag-i-introduce tayo ng correcting factor of 1/2 cosine 2x du with each of this term. Then, apply our basic knowledge in terms now to power formula or power rule. Now, diretso tayo dito. Power rule, that is now, lahat sila merong correcting factor na 1/2. So, makakancel na yan, 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 yan. Then, apply power rule doon sa ating mga exponent. That is now 1/2 sine raised to the fourth plus 1. So, 5 2x all over 5 minus 2 times the correcting factor of 1/2 sine raised to the 6 plus 1. So, 7 2x all over 7 plus the correcting factor 1/2 sine raised to the 8 plus 1 is 9 2x all over 9 plus c. Simplify further, we have 1/10 of sine raised to the 5th 2x minus 2 times 1/2 all over 7, that is 1/7 sine raised to the 7th power 2x plus 1 over 18 sine raised to the 9th power 2x plus c. Remember, in integral formula, you cannot perform integration or integrate any terms by using two rules at the same time. Hindi po pwedeng double integration yan. At that point, hindi pa pwede mag-double integration or applying two rules at one integrand. May exponent ka, so gagamitin mo power rule. Hindi pwede kasi merong trigonometric function. As long as there's no similar terms within the integrand, you cannot perform double formula or double method in one integrand.
Paano pong malalaman yung u?
Paano mo malalaman yung u?
Yes, sir. Kasi meron din naman po siyang cosine 2x, sir.
Remember, ang tawag na dito, remember that if you integrate sine x dx from your trigonometric function, that is now equal to negative cosine x. Diba? So with this is also equal to sine u du. Diba? So ang u natin dyan is x. Differential is simply dx, which has a correcting factor exactly 1:1 du. Diba? So basically, 1:1 integral of sine x dx is also, integrate mo yan, equal to cosine x plus c, or cosine u plus c. But in this example, meron tayong common terms. Kunin natin yung una. Cosine 2x of sine 4 2x dx. Okay? If we consider u equal to 2x, it has now a differential of 2 dx. Tama? But within our integrand, we cannot solely integrate an integrand that has an exponent and an integrand that is completely different from that term. So magkaiba sila, hindi sila nagko-complement with each other. So basically, gagamitin natin yung buong term, that is sine 2x, term which carries the larger exponent than the other. So mas malaki yung exponent ni sine, so yun yung gagamitin natin. Sine 2x is basically differential ni sine 2x. Remember your differential formula is cosine 2 cosine 2x dx. Simplify natin yan. That is also, dx is also equal to 1 over 2 cosine 2x du. Diba? Substitute natin doon sa taas. Meron tayong 1/2 cosine 2x of cosine 2x sine 4 2x. Constant si 1/2. Ilabas natin siya. Cancel. Sine 2x dx. Sine 4 2x dx. So, hindi mo na kailangang integrate yan dahil nag-introduce tayo ng correcting factor so that we can apply other function or so other formula para ma-integrate natin siya using power formula as it is. So, never mind that, natanggal naman na natin yung isang term, cosine 2x. So, basically, that is now equal to what? 1/2, using power formulas, raised to the 5th, 2x over 5, or 1/10 of sine 5 2x. Yun lang po yan.
Okay po sir, thank you.
Ang least na condition, ang least na assumption mo dito is to assume or to get a function that will eventually be turned to 0 after continuous differentiation. So, after differentiating more and more and more, dapat magiging 0 yung n value niya. Kung hindi, mag-introduce ka ngayon ng correcting factor. Hanapan mo ng common terms within the integrand. Kung hindi ko mahanap yung common term ni 2x dx dito sa integrand nito, why not use sine 2x? Such that if I differentiate sine 2x, meron siyang similarity with my main integrand. So, pwede ko nang ituloy yung solution ko from that point. Then, ganon ulit. Oras na. Baka pinahaba niyo maaga pa naman. Isang example pa po. Isa o dalawa pa. Number 3. What if you're now asked to evaluate the indefinite integral? The indefinite integral wait lang ha, naglalag You're now asked to evaluate the indefinite integral of sine cube y cosine raised to the 7th y dy. What if ganyan? Both of these terms or of this function has a positive odd integer. Tama? Lahat sila positive odd integer or positive exponent, odd exponents. From this point, we can express this integrand the same as sine cube y times cosine squared y raised to 3 times cosine y dy. Diba? Ganun din lang siya. Bagal mag-respond. Diba? Parehas lang. Such that cosine squared can also be interpreted based from your trigonometric identities as 1 minus sine squared y, then cube sine cube y cosine y dy. Diba? Pwede rin na ganyan. Knowing that, expand lang natin yung ating term. That is 1 minus 3 sine squared y, kasi 1 squared, minus 3 positive sine raised to the 4th y minus sine raised to the 6th y times times sine cube y times cosine y dy. Right? Ganun pa rin naman. Pinaglalaroan lang natin yung tawag na integrand which at some point pwede na natin siyang i-integrate. Ngayon, mapapansin nyo, if I distribute sine cube cosine y dy, magkakaroon na tayo ng similarity of terms. Distribute natin yan. That is sine cube y cosine y dy minus 3 integral sine squared times sine cube y cosine y, that is sine raised to the 5th y cosine y, plus 3 sine to the 4th times sine to the 3rd, that is sine raised to the 7th y cosine y dy, minus sine raised to the 6th and sine raised to the 3rd cosine y. So sine raised to the 9th y cosine y dy. From that, ano yung similarity ng bawat term na yan sa isa't isa? Same dun sa question niya kanina. If consider natin yung ating term which has a bigger exponent than the other. So si sine yung merong mas mataas na exponent kaysa kay cosine. So gamitin natin si sine. Knowing the tawag na dito, differential of sine is basically cosine y dy. Correcting factor 1:1 cosine y du. Tama? So, if I then apply this correcting factor within each of this term, I could cancel out cosine u and start performing power formula with sine cube, sine 5th, sine 7th, and sine 9th. Ganun lang. By using that condition, makakancel na yan, yan. So basically, that is now sine cube plus 1 sine raised to the 4th y over 4 minus sine 5th plus 1 is 3 over 6, which is now 1/2 of sine raised to 6y plus sine raised to 7th plus 1 is 8, 3 over 8 of sine raised to the 8th power y minus sine raised to the 9th power plus 1 is 10. So 1 over 10 sine raised to the 10th y plus c. So yan na ngayon yung ating final answer. Hanapin lang yung common terms that if ever I differentiate that term, one of them will be cancelled out. And I'll then be able to introduce a correcting factor and apply the other integral formulas without compromising each other terms. Kung yan ay sine cube y, wala si cosine y. Paano mo ngayon i-integrate yan without the common terms? Kasi kung dinefferentiate natin si sine y, wala sa ating integrand yung differential form ni sine u so that I can introduce a correcting factor and immediately apply power rule. Pero kung meron si cosine y, and if I ever differentiated sine y, I'll then be able to cancel cosine y and go straight with my power formula and solve the problem as it is. Ganun lang po. Question? Anong oras na? Aga pa. Now, last one. Para makapag-lunch na tayo. Number 4. What if you're now asked to evaluate the indefinite integral of cosine raised to the 7th 3y dy. Now, we have a term that is now tawag na dito, we have a term that also has now a positive odd integer. Tama? The integral of cosine raised to the 7th 3y dy. At this point, if I use my term u equal to 3y, that is now equal to the differential of 3y, which is now 3 dy. Pero walang similarity of terms within this integrand with regards to that differential form of 3y. And I cannot simply apply double integration. Kasi hindi pwedeng double integration in terms of power rule and integration in terms of trigonometric function. So, cannot be yung ating magiging solution with this one. With that said, I need to transform the integrand so that I'll be able to see what are the possible solutions that I could apply and simply answer the problem. So, distribute lang natin. Transform, expand, introduce identities, and basically, makikita na natin yung similar terms. If I'm going to expand this integrand, I could also express it as cosine squared 3y raised to the 3 times cosine 3y dy, which is still the same as cosine raised to the 7th power 3y dy. Tama? Parehas lang. Pinahaba ko lang. Which is also the same as 1 minus sine squared 3y raised to 3 cosine 3y dy. Diba? Parehas lang. By knowing, later on, mapapansin mo, meron ng similar terms. Mapapalabas ko na yung similar terms kasi this is already sine squared 3y, cosine 3y. Hanapin ko yung trigonometric function na may mas taas na exponent compared to the other one. Then, pwede na nating isolve yan using similar terms. Paano ngayon? Expand muna natin yung ating term kasi wala tayong hahantungan sa part na yan. That is 1 minus 3 sine squared 3y plus 3 sine to the 4th 3y minus sine to the 6th 3y times cosine 3y dy. Distribute ulit natin within the parenthesis yung ating cosine 3y. Cosine 3y minus 3 sine squared 3y of cosine 3y plus 3 sine raised to the 4th 3y of cosine 3y minus sine raised to the 6th 3y times cosine 3y dy. Ngayon, if I'm going to introduce my antiderivative or integral sign with each of these terms inside the parentheses, you may now start noticing that there are already trigonometric functions that if ever I'm going to differentiate it, will have a common term with the other one. Distribute natin yung ating antiderivative. That is now cosine 3y minus 3 sine squared 3y cosine cube y dy plus 3 sine raised to the fourth 3y cosine 3y minus sine 6 3y cosine 3y dy. May mga parehas na ba na terms? Which has the same relationship with each other? Meron na. Dito tayo sa una. Ang u natin sa part na yan is your 3y. The differential of 3y is 3 dy. So that I can easily now integrate cosine 3y without using power formula. Sabihin ko nga, hindi pwedeng mag-apply ng dalawang rule sa isang integral sign. So kung yan ay in terms of variable lang or without trigonometric function, you can apply power rule, logarithm, exponential, and basic indefinite integral application or formulas. Pero kung merong trigonometric function, kagaya nito, tapos meron pang exponent, hindi mo pwedeng pagsabayan yung dalawang rule, which is your trigonometric and your integral formulas that involves exponents. Magiging erroneous yung inyong solution later on. This is dy. That is now 1/3 dy. 1/3 du. Okay. Integral of cosine 3y or cosine y is basically what? Sine y. Meron tayong correcting factor that is now 1/3 sine 3y. Tama? Diba? From those three terms, yung natitira, meron na silang similarity with each other. Both of them is sine 3y and cosine 3y. Pare-parehas na yan. So, ang ating magiging term ngayon is sine 3y. Remember, use a term which has a higher exponent than the other. Sine 3y or the differential of sine 3y is basically 3 cosine 3y. Ngayon, meron na tayong parehas na siya doon. Doon, tsaka doon. Kalimutan ko yung dy dyan. Diba? But we still not have 3. So, kailangan natin mag-introduce ng correcting factor na 1/3 cosine 3y du. So, makakancel na yan. Cancel, cancel, cancel. And we can now perform one integration formula that is now your power formula. So, 3. That is now introduce, multiply natin si correcting factor. Lahat yan may correcting factor na 1/3. So, 1/3 sine squared plus 1. So, 3 3y all over 3. Plus 3, correcting factor, 1/3. Sine raised to the 4th is 5. Plus 1, so sine raised to the 5, 3x all over 5. Plus 1/3, yung ating correcting factor, sine raised to the 6 plus 1, that is now sine raised to the 7th y. 1/3 sine raised to the 7th 3y. 3x yun. 3y all over 7 plus c. Simplify further. We have now 1/3 of sine 3y minus 3 times 1/3 negative 1/3 sine raised to 3 3y plus 1/5 of sine raised to the 5th power 3y plus 1 over 21. Ay, minus pala yun. Ayun, minus 1 over 21 sine raised to the 7th 3y plus c. Ang haba nung problem. This particular changes or transformation of integrand is applicable only if your exponent of the trigonometric terms or trigonometric functions are all positive odd integers. Ulitin ko, positive odd integers. Yung mga in-apply nating identities, changes, expansion, transformation na ginawa natin dito are applicable only to terms or trigonometric functions which has positive odd integers or positive odd exponents. So, eto na ngayon yung ating final answer. For your exercise, try to answer problem number 5. Integrate or evaluate the indefinite integral of sine raised to the fifth power 2x dx all over cosine raised to the fourth power 2x. Okay? Kayo na pong bahala. Try to solve this problem. For your exercise, again, try to solve problem number 5. Evaluate the indefinite integral of sine raised to the fifth power 2x dx all over cosine raised to the fourth power 2x. Next meeting, diretso tayo sa transformation of trigonometric functions or trigonometric formulas under type 2 if now the trigonometric function has positive even integers or positive even exponents. Paano ngayon kung even yung ating exponents? Ibang type of identity ang gagamitin natin this time. Yung ganitong identity or trigonometric identities is applicable only for positive odd integers. Later on, iba naman for positive even integers. Okay? Stop ko na yung record.